Hello guys, welcome to Michsurd Academy. So in today's tutorial video in your practical physics, we are going to be looking at determination of slope and intercept from the graph and from the formula. Okay, now we already know that the formula for a straight line graph is given as y equal to mx plus c. Alright, so now we are going to be looking at some couple of questions that will help us to achieve this topic today. All right, so now we are not going to consider the table of value as we are not interested in the scaling in this topic. Okay, so I'll give you the questions, we'll check out the questions and also find our intercept and slope and other questions that are required. All right, so let's look at this first question here. We have that given that t, so for the first one we have given that t is equal to 2 pi square root of L over G. Okay, that we should plot a graph of t square against L, and also from the graph we should obtain the slope. We should also obtain the intercept on t square and the value of G. Okay, now where our L is the length, then t is the period, and our G is acceleration due to gravity. Okay, now what we are going to do is, since the first question says we should first of all draw or plot a graph, we have t square against L, and of course remember what we did in our last class when we talk about graphical analysis, that we are expected to put the SI unit of these different quantities. Okay, so whenever you see plot a graph of t square against L or any other variable, so the one you see first here, t square, then against L will be on the horizontal, then t square will be on the vertical side. Okay, all right, this is t, your y axis like we know, and this is your x axis like we know. All right, now so if we want to look at this equation, okay, now we are going to see that if I try to make t square the subject formula from this equation, I will have that this will be, I will first of all divide both sides by 2 pi, right? So that what I have left is L square root of L over G. So if I take the square of both sides, what I will have is t square all over 4 pi square is equal to L over G. Alright, so all we are trying to do is to make t square the subject formula, so that our t square will be equal to 4 pi square L all over what? G. Alright, so we are going to compare this equation. I'll call this equation 1a. Okay, I'll compare equation 1a with this general equation for a straight line, okay, or a straight line graph. Now this is your y-axis, this is your x-axis, right? So it's just like your t square, your y is like your t square, and your x is like your what? It's like your L. Are we together? All right, now so we can now see that when we compare, we are going to have that m, which is our slope. The slope here is called m. Okay, m here is the slope, so that the slope will be equal to 4 pi square all over what? All over G. So this gives us the what? The slope. Then our intercept, the intercept here is denoted as c from this our straight line graph equation. Okay, so that c, you see, it's just like we are adding plus 0. There's nothing here. Okay, so our c is equal to what? 0. So if you watch, we have been able to determine the slope. The slope is 4 pi square all over G. So if we are to know the value of G, okay, then pi is 22 all over 7. All right, we can calculate the what? The slope. Then the intercept will be equal to 0. So if we are to plot this graph, it means that the intercept equal to 0 means that the graph starts from the origin. okay, such that our line of best fit will cross this way, okay, so that we have this, because our intercept is what, at the origin. Okay, all right, now you see it just crossed the origin. Maybe from your experiment when performing this is a kind of typical simple pendulum experiment. Okay, if you are performing this experiment, it might likely not cross the origin, okay, might be very close to the origin. Now why is so is because of some errors that affect the experiment. So your graph might not be as perfect as this crossing the origin, okay, as the case may be. Now, so the point here is we have this line of best fit cutting this origin such that we can calculate the slope from the graph here, okay. So we draw a kind of triangle that is a right angle triangle along this line, such that this point here we can call it our L2, and this point here we call it our L1, okay. Then this other point from here we call it our T square 1. Then down to this other point from here we call this our T square 2. All right, so that the slope is also giving us the change. This is our change in t square, and this is our change in L, okay. So that it will be giving us change in t square all over change in what, in L. What does this mean? It means that we are going to have t square 2 minus t square 1 all over, we have L subscript 2 minus L subscript what, 1. So this gives us the what, the slope when we calculate from the what, from the graph, okay. Then when we use the equation, we have the slope to be what, to be this. Are we together? All right, so we have been able to plot the graph and also find the slope, the intercept. Then the next question here says the value of g. Let us calculate the value of g. So let's say we are calculating the value of g, okay. Now if you watch from here, we have that the slope m is equal to 4 pi square all over g, okay. If you watch closely, this is what we have, right? So that if we make g the subject formula, then g will be equal to 4 pi square all over what, m. So we can calculate our g once we know the what, the slope. So assuming we have calculated the slope from the graph, okay, then maybe we got from our slope, we got that the slope is equal to 27, okay, for example. Now you see that I will just put my m, my slope, into this, okay. Then I will get my what, my g, because pi is equal to 22 over what, over 7. So all the parameters or constants here are known, okay. So that is how we get the acceleration due to gravity. All right, now the other question there we have is this. They say that question 2, let's write q2 to show question 2. All right, then we have that y is equal to axn. Then we are asked to plot a graph of log y against log x, and also we are asked to determine the value of g of a, sorry, this is a, small letter a, and also the value of what, n. All right, so let's go. We are going to plot the graph first. The graph will be of this nature, such that we have log y against log x, right? Good. Now we are given this equation. This is the general form of that equation, okay, which is in a polynomial form. So we are going to take the log of both sides of this equation. If we take the log of both sides, we are going to have log of a xn, right? Now from our logarithm, okay, we have this to be equal to log a plus log x raised to power n. Now this is just a simple idea from the laws of logarithm. So we made a video on concerning the laws of logarithms. Okay, so you can check out those videos to get this clearly if you don't follow. All right, so now the point is this: we are going to have log y is equal to log a plus, now from the power law of logarithm we are going to have n log x, right? So this is what we have. Now we can rearrange this to be log y to be equal to n log x plus log what? A. Now this, we compare this equation, let's call it 2a, compare equation 2a with the general form of a straight line equation. All right, so where they have their usual meaning, the slope, the intercept, x-axis, y-axis. All right, now we see that clearly the y-axis is log what? Y, right? And our x-axis is what? Log x. Okay, that's our x-axis, log x. So clearly you can see that our slope m is equal to what? N. N can be any number. All right, then we also look at this. Also we see that our c will be equal to, which is the intercept, will be equal to everything that we have here, log what? A. Are we together? It will be equal to what? Log A. So such that my intercept, if I'm to look at this A, if A is a positive value and you're looking for the log of it, so it's clearly that the intercept might be somewhere here or anywhere along the positive y-axis. All right, so such that if I draw my line of best fit, it will cut down to this point, right? So that this becomes our what? Intercept. So that if I draw my triangle, remember from what we did in graphical analysis, we said that the triangle should cover at least 1/3 or 2/3 of the graph if possible. Okay, so that you can minimize some errors. All right, now this will be the change in log y, and this will be the change in log what? Log x. Are we together? All right, so the slope here is simply change in log y all over change in log what? X. So which is equal to, m is our slope, right? Good, which is equal to what? N. So you see we have been able to plot the graph of y against s and log y against log x, and also we have been able to determine our n, but our a here we can also determine a by taking the anti-log, so that of both sides, such that a will be equal to the anti-log of what? Of c. All right, okay, so now the other question, we are going to be a little bit fast to cover the other question. Okay, so we have that this question 3, we have 1 all over v plus 1 over u is equal to 1 over f. So they say derive an expression that will give you m to be equal to v all over f minus 1. All right, so what we are going to do is simply we are going to multiply through by v, such that if v multiplies through, we have here will be v all over v, right, which is 1, plus here will be v all over u, which is, we also have equal to v all over f, right? So that this, if you recall, we have that the magnification m is equal to v all over u. All right, so this is the image distance, v is the image distance, u is the object distance, and f is called the focal length. Okay, v is the image distance, u is the object distance, and f is the focal length. Alright, so now when we multiply through, we have this. Then our m is this, right? So that this will be 1 plus m is equal to v all over f, right? So if I make m the subject formula, I have m is equal to v all over f minus what? 1. Once our positive 1 crosses over, it becomes negative what? 1. Alright, so now this is what we have just derived. Now we plot a graph of m against v. We plot a graph of m against what? V. Of course, you consider their units like we have always said. The unit here is in cm. Okay. Then we have that the next question they ask us is that we should find the intercept and the slope, so that if we compare this equation here with the general form of this of a straight line, we are going to have that our y is corresponding to m, our c here is corresponding to minus 1. So that means our intercept is minus 1, right? So remember we plotted m against v, so that such that our slope will be 1 all over m. So we have that the slope m is equal to 1 all over what? F. Alright, so that this is the slope. We have calculated the slope, we have calculated the what? The intercept. So this means that our slope is this, our intercept is on the negative region, which is minus 1, such that if you draw your line of best fit, it will come along this path and cut the what? The negative part of the y-axis, right? So now this will be the slope. The slope is equal to change in m all over change in what? In v. So our slope is equal to change in m all over change in what? In v. All right. Now, what else? They also ask us from the graph we should determine the focal length. So how do we determine the focal length? How do we determine the focal length? Now, from here, we have that m is equal to 1 over f, right? So the focal length f can now be what? Giving us 1 all over what? The slope. So if you want to calculate the focal length, you just take 1 all over the what? The slope. So that this means that our f will be equal to change in v all over change in what? In m. Are we together? All right. So think that should be the last. Okay, we have this one, which is the last question for the day. This have to do with electricity. I'm going to run this very fast so that we can call it a day for today. All right. Now we have that given that v is equal to E minus IR, where E is the electric field, I is the current, R is the internal resistance or resistor, anyone you can call it is okay. All right, then V is the voltage. So we say we should plot a graph of V against I. All right, then also determine the slope. Now from here, remember we are plotting V against I, so I can rearrange this so that my I comes here, then I have plus what? E. You see, I did not change any sign. This is still having the negative, okay, and this is having the positive because I did not cross over the equal sign, right? So that finally you can see that if we compare with the equation of a straight line, we see that our y is v on the v is on the y-axis, and we have c, which is the intercept to correspond to the electric field. All right, so or the EMF, E is the EMF here, okay, so that our intercept is clearly the EMF, okay, and from here our slope, our x is just strictly I, which is the current, right? Then our slope will therefore be equal to minus what? R, which is the negative of the internal what? Resistance. Alright, so you see clearly that the internal resistance will be equal to the negative of the what? Of the slope, and our EMF will be equal to the what? The intercept of that what? Graph. So such that this our slope is negative value, negative slope. We are having a negative slope. Okay, so the graph pattern will change because we are dealing with a negative graph. So when we want to plot this, it will come in this form such that it will follow this path, no longer this path, unlike the others, showing that the graph is a what? A negative graph, or giving us a negative slope. So that if you check this, here becomes your I2, and this is your I1, then this is your V1, and this is your V2. So that the slope is simply V2 minus V1 all over. Now this corresponds V1 corresponds to this, and V2 rather corresponds to this, then V1 corresponds to this. Alright, so that this would be I1, no longer I2, minus I2. Instead of I2, we are writing I1 because of the pattern of the what? The slope, the graph. Alright, so this means that the value will be a negative because I1 minus I2, strictly I2 is greater than I1. So if you subtract I1 minus I2, the denominator here is a negative value, making the slope to be a negative graph. Alright guys, so this is where we are going to stop for the lecture on this. So in our next class, we are going to discuss about intercept of a graph, and also other factors like your slope, how to calculate your error in the slope, your error in intercept, and so on. So if you have not yet subscribed to this channel, I would love you to do that. Have a nice day.